Donald Lee Smith died a few years ago. He is famous for his high-power, self-powered free energy designs. There are several videos on the web showing some of his lectures. He produced one PDF document, and in May 2004 he was granted one patent. Don stated clearly in one of his lectures that he never did disclose the full details of his designs. However, Don says that he discloses enough for somebody who is experienced in radio frequency electronics to be able to deduce the things which he does not disclose, and so build a device for his own use. If that is the case, then anybody who has succeeded in doing that has kept very quiet about it afterwards, which would be understandable. Don produced at least 48 different designs which draw energy from what Don prefers to call the ambient background. His devices are capable of supplying kilowatts of excess energy, and in most cases they do not require any input energy to be supplied by the user. Don's work is subtle and not easy to replicate. It is based on the principle that the power output of a circuit increases with the square of the frequency and the square of the voltage. So if you double the frequency and double the voltage, then the output power goes up and becomes 16 times greater. As a result of this, Don's best known design uses a neon sign transformer circuit, which raises the frequency to about 35,000 cycles per second and raises the voltage to anything from 2,000 volts to 12,000 volts, giving a power output is physically quite small and yet has an output of 160 kilowatts. That's 8,000 volts at 20 amps from an input at 12 volts 1 amp. That is, the output power is more than 13,000 times greater than the input power. Consequently, his designs are for experienced developers only. Don Smith considered himself to be self-taught. He says that his understanding comes from the work of Nikola Tesla, as recorded in Thomas Martin's book, The Inventions, Researches and Writings of Nikola Tesla. This book can be downloaded from freeenergyinfo.com as a PDF file. Don states that he repeated each of the experiments found in the book, and that gave him his understanding of what he prefers to describe as the ambient background energy, which is also called the zero-point energy field. Don remarks that he advanced further than Tesla in this field, partly because of the devices now available to him and which were not available when Tesla was alive. Don stresses two key points. Firstly, a dipole can cause a disturbance in the magnetic component of the ambient background, and that imbalance allows you to collect large amounts of electrical energy using capacitors and inductors, which is a fancy name for coils. Secondly, you can pick up as many powerful electrical outputs as you want from that one magnetic disturbance, without depleting the magnetic disturbance in any way. This allows massively more power output than the small power needed to create the magnetic disturbance in the first place. This is what produces a coefficient of performance greater than 1. And Don has created nearly 50 different devices based on that understanding. Don has a website, or perhaps I should say Don had a website, but you will find that it's been taken over by Big Oil, who filled it with innocuous, similar sounding things of no consequence, apparently intended to confuse newcomers searching for information on Don's designs. The present situation in 2019 is that few people understand Don's designs fully, and I myself fall into that category. High voltage components are expensive and hard to find, and high voltages are dangerous. However, we look at one of his many designs and try to understand it as best we can. This is his tabletop device. It's a very high-powered generator. It produces a self-powered output of 160 kilowatts, which is enough to supply all the electrical needs for a row of houses. That's a row of 20 houses. The device is effectively a Tesla coil system, and so the normal electromagnetic effect of the ratio of number of coil turns does not determine the effect between the coils. His demonstration device looks like this. There's a battery which you don't see in this picture feeding this device here, which is a DC to AC alternator producing mains voltage. This device here is a variac variable transformer, which allows him to adjust the voltage applied to this device, which is a neon sign generator circuit, which steps up the voltage and steps up the frequency. The output from that is fed then via some tuning components through these brown wires to a few turns of what is effectively the primary winding of a Tesla coil. That's on a tube which can be slid in and out of this outside, difficult to see second coil here. The second coil is 3 inches in diameter and stands up on its own because it's made of very stiff wire. The output is passed on to some other components, and some of which are 4 very large capacitors wired surprisingly in series, though it doesn't look like that in the photograph, but they are wired in series to give 8,000 volts of capacitance, which allows a 20 amp output to be fed on to equipment through the connector panel here. This coil here is a choke, smoothing the output somewhat, but the interesting part is this second part here, this second winding on the choke former, is not used anymore. It was originally used to feed power back to the battery and keep it charged, but it was found that if the leads to the battery are the right length, you don't need that at all. So this coil here is unused in this particular demonstration piece of equipment. This device is not the easiest thing in the world to understand. Here is the circuit diagram. Right, the circuit diagram here shows you the battery feeding through a diode a DC to AC inverter, which output is fed to the primary coil here, which is shown on the outside of the secondary coil, which is this rectangle here. In his actual implementations, he always puts the primary coil inside the secondary coil. Not that it is critical in any way, it isn't. He has a third winding here, which is fed on to other circuitry, but the L2 secondary coil has got a capacitor across it and a variable resistor connecting to earth, and those are used to tune the operation of the L2 coil, the secondary coil. The tertiary coil here feeds on to a bridge, but not an ordinary bridge, it's a tuned bridge. The capacitor and variable resistor across the input to the bridge are used to tune the bridge to resonance with the previous circuitry. The output is then fed through a resistor divider pair to earth and on to an oscillator which drives the primary of a step down transformer to give an output which is very substantial. Now that's the circuit, and it's not a simple circuit. There are some very important points to be made here by Dom Smith in how this thing operates, and we need to pay attention to them. Grasping these points may make a considerable difference to our ability to tap into the excess energy available in our local environment. There are 4 points worth mentioning: voltage, frequency, magnetic to electric relationship, and resonance. Let's start with voltage. We tend to think of things with an intuitive view, generally based on fairly simple concepts. For example, we automatically think that it is more difficult to pick up a heavy object than to pick up a light one. How much more difficult? Well, if the object is twice as heavy, it would probably be twice as much effort to pick it up. This view has developed from our experience of things which we have done in the past, rather than on any mathematical calculation or formula. Well, how about pulsing an electronic system with a voltage? How would the output power of a system be affected by increasing the voltage? Our initial off-the-cuff reaction might be that the power output might be increased a bit. But then hold on, we've just remembered that watts equals volts times amps. So if we double the voltage, then we would double the output power. If we thought that, then we would be wrong. Don Smith points out that as capacitors and coils store energy, if they're involved in a circuit, then the output power is proportional to the square of the voltage used. Double the voltage and the output power is 4 times greater. Use 3 times the voltage and the output power is 9 times greater. Use 10 times the voltage, the output power is 100 times greater. This is a graph of the way that voltage alters, or output power alters with voltage. The graph itself is an exponential graph, and it goes up rapidly. So Don says that the energy stored multiplied by the cycles per second is the energy being pumped by the system. Capacitors and inductors temporarily store electrons, and their performance is given by formulas. For a capacitor, watts is equal to half of the capacitance multiplied by the square of the voltage multiplied by the cycles per second. In the case of an inductor, watts is equal to half of the inductance times the current squared times the cycles per second. You'll notice that where inductors, that's coils, are involved, then the output power goes up with the square of the current. So if you double the voltage and double the current, you'll get 4 times the output power due to increased voltage, and that increased output is increased by a further 4 times due to the increased current, giving 16 times the output power. Let's take a look at frequency. You'll notice from the formulas that the output power is directly proportional to the frequency called Hz or Hertz. The frequency is the number of cycles per second or pulses per second applied to the circuit. This is something which is not intuitive for most people. If you double the rate of pulsing, then you double the power output. When this sinks in, you suddenly see why Nikola Tesla tended to use millions of volts and millions of pulses per second. However, Don Smith states that when a circuit is at its point of resonance, resistance in the circuit drops to 0, and the circuit becomes effectively a superconductor. The energy for such a system which is in resonance is watts is equal to half times capacitance times the voltage squared times the cycles per second squared. If this is correct, then raising the frequency in a resonating circuit has a massive effect on the power output of the device. The question then arises, why is the main power in Europe just 50 cycles per second and in America just 60 cycles per second? If power goes up with the frequency, then why not feed households at 1,000,000 cycles per second? One major reason is that it's not easy to make electrical motors which can be driven with power delivered at that frequency. So a more subtle frequency is chosen or a more suitable frequency is chosen in order to suit the motors in vacuum cleaners, washing machines, and other household equipment. However, if we want to extract energy from the environment, Then we should go for high voltage and high frequency. Then when high power has been extracted, if we want a low frequency suited to electric motors, we can pulse the already captured power at that low frequency. It might be speculated that if a device being driven with sharp pulses which have a very sharply rising leading edge and a very sharply dropping trailing edge, that the effective frequency of the pulsing is actually determined by the speed of that rising edge, rather than the rate at which the pulses are actually generated. For example, if pulses are being generated at, say, 50,000 per second, but the pulses have a leading edge which would be suited to a 200,000 cycles per second pulse train, then the device might well see the signal as a 200,000 cycles per second signal with a 25% mark space ratio, the very suddenness of the applied voltage having a magnetic shocking effect equivalent to a 200,000 cycle per second pulse train. Alright, let's take a look at the magnetic to electric relationship. Dunn states that the reason why our present power systems are so inefficient is because we concentrate on the electric component of electromagnetism. These systems are always coefficient of performance less than 1. That is, the output power is always lower than the input power, as electricity is the losses part of electromagnetic power. Instead, if you concentrate on the magnetic component, then there is no limit on the electric power which can be extracted from that magnetic component. Contrary to what you might expect, if you install a pickup system which extracts electrical energy from the magnetic component, you can install any number of other identical pickups, each of which extract the same amount of electrical energy from the magnetic input without loading the magnetic wave in any way. That gives you unlimited electrical output for the cost of creating a single magnetic effect. The magnetic effect which we want to create is a ripple in the zero-point energy field, and ideally we want to create that effect while using very little power. Creating a dipole with a battery which has a plus and a minus terminal, or a magnet which has a north and south pole, is an easy way to create an electromagnetic imbalance in the local environment. Pulsing a coil is probably an even better way, as the magnetic field reverses rapidly if it's an air-cored coil, such as the Tesla coil. Using a ferromagnetic core to the coil can create a problem, as iron can't reverse its magnetic alignment very rapidly, and ideally you want pulsing which is at least 1,000 times faster than iron can handle. In a typical Tesla coil, the primary coil is much larger diameter than the secondary coil, which is down the middle. If, for example, 8,000 volts is applied to the primary coil, which has got 4 turns, then each turn would have 2,000 volts of potential across it. Each turn of the primary coil transfers electromagnetic flux to every single turn of the secondary winding, and the secondary coil has a very large number of turns. Massively more power is produced in the secondary coil than was used to energize the primary coil. A common mistake is to believe that a Tesla coil can't produce serious amperage. If the primary coil is positioned in the middle of the secondary coil as shown above, then the amperage generated will be as large as the voltage generated. A low power input to the primary coil can produce kilowatts of usable electric output power. We then come to the interesting topic of resonance. An important factor in circuits aimed at tapping external energy is resonance. It can be hard to see where this comes in when it is an electronic circuit which is being considered. However, everything has its own resonant frequency, whether it's a coil or any other electric component. When components are connected together to form a circuit, the circuit itself has an overall resonant frequency. As a simple example, consider a swing. If the swing is pushed before it reaches the highest point on the mother's side, then the push actually opposes the swinging action. The time of one full swing is the resonant frequency of the swing itself, and that is determined by the length of the wire or ropes connecting the seat of the swing to the swing frame. The wire length holding the seat, and not the weight of the child, nor the power with which the child is pushed, has an effect. Provided that the timing is exactly right, a very small push can get a swing moving in a substantial arc. The key factor is matching the pulses applied to the swing, that is, to the resonant frequency of the swing. Get it right, and a large movement is produced. Get it wrong, and the swing doesn't get going at all. At which point critics would say, see, swings just don't work. This proves it. Establishing the exact pulsing rate needed for a resonant circuit is not particularly easy because the circuit contains coils. The coils have inductance, capacitance, and resistance. The circuit also contains capacitors, which have capacitance and a small amount of resistance. And it contains resistors and wires, both of which have resistance and some capacitance. These kinds of circuit are called LRC circuits because L is the symbol used for inductance, R is the symbol used for resistance, and C is the symbol used for capacitance. John Smith provides instructions for winding and using the type of air core coils needed for a Tesla coil. He provides quite an amount of information on this device, which we're taking a look at, and without his description of the device it would be difficult to understand its construction and method of operation. As I understand it, the circuit of what is mounted on his board is as shown here. You have a 12-volt battery feeding through a diode to a DC to AC inverter. You have an optional variable voltage transformer which allows you to control the voltage applied to the neon tube driver circuit. It incidentally has two outputs, so two diodes are used to connect both sides of this particular unit to give an output. The output is used to charge a capacitor C. A spark gap triggers when the voltage across C gets big enough, and that operates a major pulse to the L1 primary coil of your Tesla coil, which in this instance is shown split in two because that's the way that Don has it physically constructed. A capacitor then across the output of the circuit is fed across and feeds a very large capacitor. This is an 8000 volt 2 microfarad capacitor, which is large and expensive. And then there is a suppressor coil, which is not too important but is used in this circuit to give the output, which can be 8000 volts at 2 amps, 8000 volts, 2 amps, 160 kilowatts. This is a major output. Anyway, the electrical drive is from a 12-volt battery, which you don't see in the photograph. Interestingly, Don remarks that if the length of the wires connecting the battery to the inverter are exactly 1/4 of the wavelength of the frequency of the oscillating magnetic field generated by the circuit, then the current induced in the battery wires will recharge the battery continuously, even if the battery is supplying power to the circuit at the same time. So this is how the operation goes. You've got a battery feeding sine wave inverter. You've got a variable transformer allowing you to specify the AC voltage applied to your neon tube driver circuit. The circuit steps up the frequency and steps up the voltage. You've got some components here which help tune to a resonant frequency, and the output through these brown wires goes inside this inner plastic tube and comes out to give the few windings of the primary winding. This slides inside the secondary coil. The secondary coil supports itself. It's not on any former. It's made of thick wire, and the turns are separated, and in the middle the tap is taken off from the secondary coil and fed on to feed the output circuitry. Interestingly, this is the choke to smooth the output, and this coil here was originally used to power a circuit which fed the battery and kept it up to its full voltage. But in this circuit nowadays, that coil is redundant. It is not used at all. Now, this is the way that the particular circuit operates. You may not see it in the circuit itself very clearly, but there is a spark gap or gas discharge unit here. It looks like this, and it operates inside an inert gas contained inside the container. Now, the thing you need to understand about the earth is that in the circuit diagrams, when an earth connection is mentioned with any of Don Smith's devices, we're talking about an actual wire connection to a metal object physically buried in the ground, whether it's a long copper rod driven into the ground, or an old car radiator buried in a hole like Tariel Capanazzi likes to use. When Thomas Henry Morey was performing his requested demonstration deep in the countryside at a location chosen by his skeptics, the light bulbs which formed his demonstration electrical load glowed more brightly with each hammer stroke as a length of gas pipe was hammered into the ground to form his earth connection. It should be remarked that since John purchased his neon tube driver module, that newer designs have generally taken over completely, especially in Europe, and these designs have built-in earth leakage current protection, which instantly disables the circuit if any current is detected leaking to ground. This feature makes the unit completely unsuitable for use in a Don Smith circuit, because there the transfer in current to the ground is wholly intentional and vital for the operation of the circuit. However, you can easily make your own neon style module equivalent with a car ignition coil if you want to. You have a 12-volt battery. It's feeding a capacitor to give a smooth input to an ordinary 555 chip. This part forms the oscillator, and the output of the chip goes to the gate of a P-type FET transistor, which has a protective diode across it to keep the transistor safe. The transistor drives current through the primary of the car coil, which is a high voltage step-up transformer, and that's passed in through a diode, high voltage diode, with a tiny capacitor across it to give the stepped up output high frequency voltage. This is a simple circuit which you can use to drive the L1 primary of a Tesla Coil style transformer. This looks ever so simple and straightforward, but there are some subtle details which you need to be considered. Much more on this is in the Chapter 3 document, PDF document on freeenergyinfo.com if you're interested. However, making a high power device like this is not easy to do, and very few people have accomplished it. But there is an easier approach if you're not interested in powering a row of 20 houses. A Ukrainian student, I am Solovey, was not satisfied with the many errors in conventional science, and he decided to write his PhD dissertation on the lack of information on free energy. Just like Don Smith, his experimentation was with the Tesla coil, but he avoided expensive high voltage components, and while his output power was much lower, his objective was to show that free energy exists. The translation for his application is shown below, and thanks is due to Howard Haley for making this translation. His paper was entitled Electric Power Generation System High Frequency, and he talks in his paper about he says that currently there's a great deal of information about devices after which activation, in whatever working field, the process of relaxation, output energy, is in excess of the input energy used. For example, the production of thermal energy observed in the oxygen-hydrogen electrolyzers for normal and heavy water, and the electric discharger, and the vortex heat generators. In the late 1980s, Stanley Mayer's patent for the water fuel cell that allows the conversion of ordinary tap water into hydrogen oxygen with far less expenditure of energy than would be required by conventional electrolysis, and in much greater quantity than expected with simple electrolysis. His explanation of the results is based on the resonant electric field effects on water molecules. Later, Don Smith built a number of devices based on Tesla's experiments, mostly with high output power. In his articles, he notes that he repeated each of the experiments found in the Tesla books, and this gave him his understanding of ambient background energy. His objective was to repeat one of the above methods of obtaining energy, to test whether these devices really do work. For this, he says, we implemented the circuit of the Don Smith device from his patent of 1999, where his generator can achieve an output of 15 kilowatts. This is the circuit that he shows. Now, I'm not aware of any patent from Don Smith which contains this particular circuit diagram, nor of any patent in 1994. But then, perhaps he's got one that I don't have. The basic materials and method of research, he says, the main elements in the schematic of Figure 1 is an air core transformer with the windings numbered 6, which is the primary, 6A, which is optional, 7, which is the secondary. For this study we prepared primary L1, secondary L2, and an additional L3 coil according to the details in this following table. For the L1 coil, the coil length is 5.5 or 5.5 centimeters, 55 millimeters. The number of turns on the coil is 8. The diameter of the coil former is 5.5 centimeters. The finished coil had a resistance, DC resistance of 0.1 ohms. The length of copper wire used to wind the coil is 1.4 meters, and the wire diameter used was 2 millimeters. For the secondary coil, he had a 32 centimeter length when it was finished. It took 463 turns to do that. The diameter of the former was 5.1 centimeters. The DC active resistance of the finished coil is 4.2 ohms. The length of copper wire used in winding the coil was 69.1 meters, and the wire diameter used was 0.65 millimeters. His additional coil, L3, was 6 centimeters long. It had 10 turns in it. It had a former diameter of 5.6 centimeters. The resistance measured in DC ohms when checked out after winding was 0.1 ohms. The length of wire needed was 1.8 meters, and the wire diameter was 1.2 meters. Sorry, 1.2 millimeters. They used a program to calculate the expected results from his windings and so on, and he quotes the actual results here. Then he goes on to do a test. He placed the L1 winding at the bottom of his L2 winding. This sketch I've done here is has the L1 coil a little high. It actually should be pretty much on the base board itself, because he says he put the primary at the base of the secondary. Now this is the circuit that he used. He applied 14 volts DC, put a capacitor across it, and then he developed this very complex circuit which comprises of 2 resistors and 1 transistor and 2 coils. Very difficult. But that circuit, where he has a 2.2k resistor and a 160 ohm resistor feeding the base of the transistor itself, the transistor is an NPN bipolar type, driving the L1 8-turn primary of his system. This is the arrangement that he used for his test. He measured the voltage across the secondary, 463 turn secondary, and found it was around 700 volts. So you want to be careful dealing with systems where the voltage gets stepped up. This is not actually a toy. Now, the experimentally determined values of voltage was that the frequency that this circuit generated was 1.1 megahertz. That is, this circuit oscillates at more than 1,000,000 times a second. So as well as having a very high voltage, it has a very high frequency coming out of it. He says when connecting the circuit in figure 2 to the constant power supply, the power consumption was 0.3 amps, that's 300 milliamps, and that at 14 volts is 4.2 watts of power being pushed into the circuit. When you look at the output, you have 300 milliamps at 700 volts, which is 210 VAR. That is considerably extra power output. They used bulbs as the assessment of output. In all these figures, 3, 4, 5 and 6, the bulb was used, and they used the brightness of the lamp to give you an indication of the approximate output power. He used various different lamps from 0.3 watts to 21 watts. With this circuit in figure 3, 0.3 watts did not lead to lighting in the bulb, although 4.2 watts of energy was being pushed into the circuit. They decided to add on a third coil, the L3 coil of 10 turns. They put it in the upper third of the L2 coil physically. A 6 volt 3 watt amp lamp was connected to the additional coil L3, but the lamp only showed a subtle glow. Then they decided to put a capacitor in series with the winding L2. So L2 goes through a capacitor to earth. The L3 10 wind coil is still feeding the lamp. The lamp became brightly lit, and in 4 to 5 seconds it burned out even though it was a 21 watt 12 volt bulb. The consumption of current for the circuit was 1.2 amps typically. You got a very similar result when you put a tungsten lamp in series with the capacitor that's going back to earth from the L2 coil. 21 watt 12 volt bulb in that position burnt out in 4 to 5 seconds. The current consumption in the circuit certainly didn't go above 2.3 amps. His conclusion was that exploratory studies confirm the existing scientific thought that the processes of input and output transmission of electricity using high voltage, high frequency electromagnetic field radiation phenomena requires further deep theoretical and experimental studies. And this interesting thing about this paper from our Ukrainian student is that the input voltage is so low, at a mere 14 volts, although of course the output voltage is much higher and is also at more than 1,000,000 cycles a second. The final diagram is interesting in that his 21 watt 12 volt bulb was destroyed in just a few seconds. The measurement of current through the bulb was supposedly 2.1 amps, while the bulb's design current is 1.75 amps. That difference between 1.75 and 2.1 amps is not enough to have destroyed the bulb so rapidly. So the problem will have been that the bulb wattage was exceeded very severely. Earlier, the voltage across the L2 coil was measured at 700 volts, so there may have been as much as 700 volts applied to the 12 volt bulb. If 700 volts are applied to the bulb and a current of 2.1 amps flowed through the bulb, then the dissipated power in the bulb would have been as much as 700 times 2.1, which is 1,470 watts, which is 70 times the rating for the bulb, and it's more than 1 kilowatt. Please don't be misled by the 14 volt input voltage, as this circuit steps up the voltage and it might kill you. It's said that the high frequency of 1.1 megahertz makes the output harmless to humans. I have not tested this, and you really need to be careful around any high voltage circuit. A point which he missed in his dissertation is the fact that the positioning of the L1 primary coil along the length of the L2 secondary coil has a major effect on the output amperage. So positioning the L2 coil in the middle of the L1 coil should increase the output power very considerably. The lamp used as the load is essentially a resistive load. I don't know enough about the subject, but putting a simple step-down air core transformer in place of the bulb should lower the output voltage and increase the available output current very considerably. It might well be worth testing this simple circuit.